we're still solving arithmetic sequence problems. We're still solving problems where you have a first term and you have a common difference. Okay? And this is a question that somebody had asked about. It's not the same question. If it is, that's just a fluke. But what we're given here are three terms of an arithmetic sequence, and they're algebraic in nature. The first term is 3x plus 2, the second term is 17, and the last term is 10x minus 7. Okay? X has a particular value. It says find x. Well, look, can we just try something here? It's not going to work. But if x is 1, I would like everybody to calculate what this would be equal to if x was 1. And it's not a difficult task I'm putting in front of you. 3 times 1 plus 2. You get 5, don't you? If x is 1, and please don't write this down, if x is 1, then the first term would be 5. You're told the second term is 17. And if x is 1, what is the value of this? Well, I would have to take 10 times 1 minus 7. And again, I'm choosing 1, which is not a difficult thing to do. The calculation with 10 times 1 is 10, minus 7 is 3. So my question that I put to you now is this arithmetic? No, so obviously x is not 1, right? But if you take this approach and you start putting in different values of x, then what you're really talking about is trying to solve it like a puzzle. And I think solving problems in math by approaching them as being puzzles is a very bad approach. Because you could have 15 different problems that in fact could all be solved using the same method, but if you solve it as if you have 15 different puzzles, it's very difficult. So what we're going to do to solve this type of question is very specific. We are going to say that if I were to take the second term minus the first term, that would give me the common difference, wouldn't it? Do you agree? But do you also agree that if I were to take the third term minus the second term, that's another way I could find the common difference? Okay. That means this. It means that when you take the second term and subtract the first term, you have to get the exact same thing that you would get if you took the third term and subtract the second one. And I'm going to write down now what this becomes when I use the first, second, and third terms, but I'm going to purposefully put a mistake in here. And it's a mistake that's so common, people make it in math, in calculus. In my calculus class, we make the mistake. It's very easy to forget to do something, but if you make this mistake by forgetting to do this thing, you'll get the wrong answer. So T2 minus T1 equals T3 minus T2. So I took the second term, which is 17, and I subtracted the first term, which is 3x plus 2. I set it equal to the third term, which is 10x minus 7, minus the second, which is 17. But there's a mistake there. Charlie. We need brackets. Anytime you subtract something, that's right, anytime you subtract something, you should have it in brackets. Now, you'll notice I didn't say anytime you subtract something, you need to have it in brackets, because we don't need to put that 17 in brackets, because it's a single item. So when I subtract 17, whether it's in brackets or not doesn't matter. Now we have to talk about how you've been taught to handle this bit of business that I have over here. So let me tell you how I do this. I peel off the brackets and say to myself in my head, I am subtracting 3x and I am subtracting 2. How many of you were taught remove the brackets and change the sign on everything inside the brackets? How many of you were taught imagine there's a 1 here and multiply that negative 1 by the 3x and by the 2. Okay. There's all kinds of ways you can handle it. But the bottom line is you end up with 17 minus 3x minus 2 equals 10x minus 7 minus 17. And so now you know me, even after a couple of days. It's not all about content. It's not all about sequences and series and all this stuff. Right now it's about math. You have an equation, and you're often told by earlier grades or in earlier grades and classes by your teachers, one of the first things you should do is simplify. And I just want to stress something here. Yep.
Shouldn't you have the brackets on the 10 and the negative 7? And then just be flipped to the bottom?
I'm going to get back to that in a second. The answer is no. Okay? And I'll explain why in a second. But let me finish my thought here. When your teachers say simplify, don't get caught in the trap of, you may have been told simplify means multiply. That's not what simplify means. Simplify means make simpler. That's what simplify means. And 17 minus 2 is not as simple as 15. Right? We always work in math with algebra to turning things into things that are simpler, basically by saying this is something we would have seen in an earlier grade. That's what qualifies as something being simpler. And then over here we have 10x minus 24. And I also have the minus 3x here. Negative 7 and negative 17 is negative 24. The question has been asked, do I need brackets around this? And the answer is no, because whenever you subtract something from an item, when you subtract B from A is already your starting point and you're subtracting something from it. It's not like, I guess maybe I should come up with an analogy. And are you okay with me using plus 7 here as a different question to illustrate my point? Okay. So imagine that I had 10x plus 7. This is a different universe right now than the one we're in. It's a different question. And I'm going to take away 12. Why don't I need brackets here? Well, this would be very similar to me saying that I have my commission in a job, which is a certain percent of the sales that I make, plus I have my other pay, and you're going to subtract taxes. The fact of the matter is, I add this stuff together to begin with, and whatever I get, I'm simply going to subtract the taxes from it. I only have to worry about something being in brackets if I'm subtracting that whole thing. Another way to look at it is, this is really a plus, isn't it? It's money coming in. It's a good thing. So I don't need brackets. I could just go plus the commission plus the pay. The brackets are not necessary. Another thought that I will just throw out there is, there's certainly nothing wrong with you putting this set of brackets here. But what are you going to do with them in the next step? You're just going to remove them, aren't you? Because it's plus, you're just going to remove the brackets. And when we remove the brackets, we're back to the beginning where we didn't even need the brackets. You've asked a very tricky question for me to explain the answer to. But the bottom line is, when you subtract, you need brackets around the thing you're subtracting, not around the thing you're subtracting from. Okay? All right, so now we're at this stage and we have to solve that. And I'm missing, I don't know why I wrote 13 there. Maybe I was thinking ahead to that question. This is 3x, correct? Okay. Now we're back to that discussion I had about positives and negatives. If I want to solve this, I have to move all of my x's to one side and all of my numbers that are not x's to the other side. But I don't want to work with negative x's. I would rather work with positive x's. So since I have positive 10x on the right and negative 3x on the left, if I move my x's to the right, I'm going to add 3x to both sides and get 13x. I'm fine with that. But if I move my x's to the left, I'm going to have negative 13x. I'm telling you that I would much rather do this. And I know you're used to solving things where x is on the left, but we have to graduate past that at this level. It doesn't have to be x equals. It can be something equals x. And I'm going to add 24 to both sides, and I get 39 here. I didn't show plus 24 and plus 24. And I don't think you really need to show plus 3x plus 3x. Are we okay to that step? Okay. Divide both sides by 13. 39 divided by 13 is, I believe, 3. So what we've done is we've found the value of x to be 3. Now, let's confirm that. In this question up here, it says, what is the value of the first 3 terms? Well, I got to put my value of x that I got in to each of these. So what do I have? I have 3x plus 2. I have 17, and I have 5x minus 10x minus 7. Thank you. I have 10x minus 7. So when I put 3 in here and here, what do I get? Well, I get 3 times 3 plus 2. I get 17, and I have 10 times 3 minus 7. Let's see, this is 11. This is 17. Without looking any further, I can see if I did it right, my common difference is 6. 11 to 17 is 6. 17 plus 6 is 23. I'd better get 23 here. And I do. 3 times 10 is 30. 30 minus 7 is 23. So we've solved the problem. X is 3. Those are the first 3 terms. The common difference is 6. And that's how you would do that question that you asked about that's in the extra practice in your handout. Okay. Any questions with any of the work we did there? All right. Let's look at another one. The third term of an arithmetic sequence is 30, and the 10th term is 114. Find the first term and the common difference by using a system of equations. Now, first of all, I want you to understand there's a quicker way to do this. And I will show you the quicker way. And in fact, we've done this problem before. But solving a system of equations is something that you're probably going to have to do in every unit in the rest of this course somewhere. And in every unit in Math 30-1 somewhere. So by doing one here, you get used to the method. I had a good conversation this morning with a few students in this class. I could show you the quick way to do this, but that quick way to do this would not be a way that you could solve 100 other problems which could be solved with a system of equations. I'm teaching you about a general tool here that can be used for lots of applications. The quick way of doing this is limited to this specific question. Okay. So, what is it we need to answer this question? Well, we need to know the first term and the common difference. That's what the question is. And by the way, everybody, if you know the first term and the common difference, you've cracked the case wide open, haven't you? Because if you know the first term and the common difference, you can find the second term and the third term, etc. So how do we do this? Well, remember that these are parameters. Those are called parameters. And although not everybody has the benefit of the conversation we had this morning with the 3 students, those 3 students will understand that we have 2 parameters here that are missing. And I would like everybody now to focus on that phrase. We have missing parameters. The reason is, and I don't feel the need to explain my reason for teaching things the way I do all the time, but here I think it's important. I am trying to teach you something that is useful in many areas. As soon as you have missing parameters in trigonometry next year, in rational expressions this year, in quadratic equations this year, as soon as you have missing parameters, you solve the problems the same way all the time. All the time. Doesn't matter what the topic is. Okay? So the first step is to use our formula and put in, well, let me back up. The first step normally in coming up with this equation would be to put in the two parameters, to put in T1 and D, but we don't know them, right? However, we do know this. And I would like you, after you write that down, to mentally digest what that table is telling you. You're told in the question that the third term is 30. You're told in the question that the 10th term is 114. There's a lot going on here, but let me break down something for you. Would you agree that T1 and D are going to be numbers? Okay. What's the difference between the numbers that T1 and D are and these numbers? Is that these numbers at the bottom of the screen are variable. Each term has a different pair of those numbers. But when you use this formula at the top of the screen to calculate, I don't care, the 100th term, you're going to have to make use of T1 and D. It's the same for every calculation. What we're going to do is put in the 3 and the 30 in this equation. And this is the general strategy. We're going to come back to this again and again and again. But for those 3 people I was speaking with this morning, I told them to find a missing parameter, you put in a pair of numbers that makes the equation true. And that's what we're doing. Thank you. Should be 3 minus 1. So we put in this pair of numbers, and I can't stress this enough, that these numbers go together. The 3 goes with the 30. When you put 3 in for n, the 30 comes out. You can't just randomly put in, say, the 3 for n and the 114 for tn. They don't go together. So we have an equation, and I would like you to label this equation as equation 1. As equation 1. In fact, let's do something with it. Let's write 30 equals T1 plus 2D. I mean, isn't 2 a lot simpler than writing 3 minus 1? I think. Let's do the same thing now with the second pair of numbers. The second pair of numbers, again, is a pair of numbers that are inextricably locked together. When n is 10, tn is 114. They go together. I can't use one without the other. This means that if I were to put into this top equation these two numbers, I would write 114 equals T1 plus 10 minus 1 times D. This is going to be equation 2. And of course, we could simplify that to 114 equals T1 plus 9D. And we have 2 equations. We have this equation, which I've chosen to call equation 1. We have this equation, which I've chosen to call equation 2. And if I said to you in the blue equation, solve for T1, calculate what T1 is by rearranging the first equation, you can't do it, can you? Because you don't know D. And if I said, well, okay, then find D first. You can't do that because you don't know T1. And this is what you learned in Math 10C, was that this pair of equations is called a system of equations. And if you have two unknowns, it's possible to use two equations to find the solution to the problem. I realize grade 10 math was a while ago for some of you, but if I were to take the green equation and write it above the blue equation, then I could subtract the two equations, and the significant accomplishment would be that T1 would disappear. Right, I'd have 114 minus 30. That'll give me a number, 84, I think. T1 minus T1, nothing. And then 9D minus 2D is 7D. I am, however, going to try to impress on you something that might be helpful. Would everybody agree, I think, subtraction is more complicated than addition? I mean, just in a very general sense. You learn how to add in elementary school before they start talking about subtraction. It's a little more complicated. We got those goofy rules that when you're subtracting, you need brackets sometimes, right? It's complicated. So rather than subtracting these equations, my thinking is, let's multiply the bottom equation by -1 and add the equations. I know there's no difference. No pun intended. They're the same result. But to me, students make fewer mistakes if you multiply one of the equations by -1 and add them. So when I add these, I get 84. Is this coming back to you, systems of equations from grade 10? Very last unit in the course. No? Okay. You know what it amounts to, everybody? Is taking these two equations, equation 1 and equation 2, and using all of your mathematical algebraic prowess skills to figure out what the two numbers are. That's what it amounts to. So I'm going to add these. I get, I think it's 84. Can somebody confirm that? Okay. T1 plus -T1 is a wash. There's nothing left. And then 9D plus -2D is 7D. Now I know D. Well, not yet. I have to divide both sides by 7 and get what I think is 12. Okay. So I divide both sides by 7 and I get D is equal to 12. Now I'm halfway home, right? I just need to know the first term. But I have a multitude of equations. I have lots of equations up here that I can use along with the fact that D is 12 to find the first term. I can use this one. 30 equals the first term plus 2 times 12. That should be like stealing candy from a baby. Very simple. You just reach over and you take it away. No problem. 2 times 12 is 24. Take 24 away from 30 and you get what I believe is 6 when you solve that. So now we know that the first term is 6. And we've answered the question. The first term is 6, the common difference is 12. I want to point out to you the simple way to do this question. But again, it's only a simple way to do this question. This method that we've used can be used to solve thousands of questions, different types of questions. But what I'm going to show you will only work in this unit for this specific question. You were told the third term was 30, correct? 1, 2, 3. You were told the 10th term was 114. 4, 5, 6, 7, 8, 9, 10. What is it you add to 30 to get to there? Well, you add 1, 2, 3, 4, 5, 6, 7 common differences. In fact, we kind of did a question like this on day 1. where if I told you the third term was 30 and the 10th term was 114, I forget who said it, but the person said, well, since we're going from the third term to the 10th term, it's 7 common differences, because from 3 to 10 is 7. Well, that just means 30 plus 7d equals 114. And I wanted to point something out to you. When you take 114 minus the 30, you get that 84. And the 7d comes about because we took 9d minus 2d. The result would be the same. Okay, let's try another one. Totally different question now. And there's some typing mistakes in your handout here. An HVAC technician makes house calls and bills her clients using the schedule shown to the right. So she gets a phone call, she goes to a house. If she's working there for anything under an hour, the billing amount is $115. If she's there for anything up to and including 2 hours, she bills $155. Notice she doesn't bill for 2 hours twice the amount she bills for 1 hour, because part of that $115 is a cost of going out there, of driving, of making the house call. Okay? But you will also notice, I hope, that you can see this goes up by $40 and this goes up by $40, making these arithmetic. And what that's telling me is she's charging $40 an hour. And anything else is a cost, a flat cost of getting out there. So if it says, if these form an arithmetic sequence, write a general term for the billing amount if, yours says is, if, I think yours says is, if the number of hours corresponds to the term number. Well, what we're talking about then here is T1 equals 115 and D is 40. Listen, this is not a difficult problem. It's just an application. Some of you may find it difficult because you have to take the words and turn it into math. It's a word problem. But what we're talking about here are the terms being the charges and the term numbers being the number of hours. We throw this into the formula, and we had lots of practice with this yesterday. We throw in the two parameters and get Tn equals 115 plus n minus 1 times 40. And what we need to do is multiply that out. Right, you need to multiply that 40 by the n minus 1. Simplify it. I'll give you a second or two to do so. Once again, we're doing this. Should be no problem getting plus 40n minus 40. So we end up with T sub n equals, 75? Is that right? Thank you. 75 plus 40n. This should totally make sense in terms of the context of the question. Her flat fee for driving to your house is $75. Plus she charges $40 an hour. That makes sense. And not only will it make sense, it will be a useful tool in predicting any connections here. If I said, and I think in one of these questions, what if it's a 6-hour call? Something like that. Well, then we can put 6 in for n. Speaking of which, take a look at the next question. I don't know why I didn't bother to proofread. I changed this question in my note package, and I typed it up, and I sent it to the printer, and I didn't even bother to read what I typed. It looks like maybe I was having a seizure or something when I was typing what's on yours. But it should say, if a bill was $315, then how many hours was the call? So I've put over here, here's this tabular idea again with the two variables. I've put over here, and your structure looks a little bit different than mine, But this column is n and this column is tn. So in B, you're asked to find tn if you know n. And that is really simple because we don't even need to rearrange anything. You just put n equals 6 in there and you do the calculation, right? It's just a calculation, that's all. It's going to be T6 is 75 plus 6 plus 40 times 6. I think that's $315. Oh, wow. Well, that's going to make the next question pretty easy. That's $315. Okay. I got to make a note to change my notes. Let's do this instead. If the bill was $395, how many hours was it? Now, I realize you could probably just figure that out by looking at the fact that 6 hours was $315, but let's do it algebraically. What you would now have is the same equation, but this time you're putting Tn in, and you're solving for n. And by the way, as simple as this is simple too, isn't it? To find n. It's a little bit less simple. You have to take 395 and subtract 75. What does that give me? 320 equals 40n. So divide both sides by 40 and you get 8. Is that okay? Any questions with that one? All right. One final question. Jonathan has a part-time job working in a grocery store, and he's going to create a display of cereal boxes. He's going to stack cereal boxes in layers. And the number of boxes in each row or layer produces an arithmetic sequence. There are 16 boxes in the third row from the bottom, and there are 6 boxes in the 8th row from the bottom. Okay. Well, believe it or not, this is a question we've done, I count 5 times. The math in this question we've done 5 times so far in this course. Twice today. The bottom line here is you can say, since there are 16 boxes in the third row from the bottom, that when n is 3, the term value is 16. By the way, when we set it up this way, since I'm told that it's the third row from the bottom row becomes T1. T1 is the bottom row. And you're told that there are 6 boxes in the 8th row from the bottom, so when n is 8, this is 6. And by the way, you can see that the number of boxes, this is the number of boxes. I may have even given you a table there, did I? I did. This is the number of boxes, and this is the row from the bottom. You can see the number of boxes gets smaller as you go further from the bottom, and that makes sense. If you stack boxes, you don't stack them so you have more boxes in higher rows, right? It's more like a pyramid. It goes that way. So how many boxes are in the bottom row? Well, this question is asking you, what is T1? This is the same as example 2 in this lesson, except we're not going to solve it with a system of equations. We're simply going to say that to go from the third row, which has 16 boxes, 4, 5, 6, 7, 8, to the 8th row that has 6 boxes. Did I write the numbers down right? I just want to make sure. 3 is 16, and 8 gives us 6. To go from that third row to the eighth row, you add 5 common differences. Quick question, just by a quick show of hands. How many of you don't need to write out all those blanks to know it's 5 common differences? Okay, and that's good. If you do, that's okay. But you don't need to. So the quickest strategy here for this specific question is to do this and to solve that for D. Now, we have positive 5D on the left, so it makes sense to leave that alone, subtract 16 from both sides, and then divide the result by 5. And when I do that, I end up with 5D equals negative 10, and that gives me negative 2 for D. Let's see if that makes sense. We don't always have to do things algebraically. If I add negative 2 to 16, I get 14, then I get 12, then I get 10, then I get 8, jackpot, I get 6. So what's the quickest way for us to find the number of boxes in the bottom row? Not to use a formula, to just go in the other direction. Right? If this is 16, this must be 18, this must be 20. The first term is 20. And again, the idea of showing work and doing things algebraically is important, but sometimes you're just given a problem, you want to solve and get the answer to the problem. B, what's the general term? Okay, well, we keep doing the same thing over. We've done this at least 4 or 5 times. The first term is 20. Whoops. The first term is 20. The common difference is negative 2. We load those into this, and we simplify. That's it. It's just in the context of cereal boxes. Tn equals 20 plus n minus 1 times d, which is negative 2. Multiplying that out, n times negative 2 is negative 2n. Negative 1 times negative 2 is 2. So I get Tn equals 22 minus 2n. And you could check it out. You could put in n equals 1 and n equals 2 and n equals 3 and see if you get the terms, and you will. And the final question, if the top row, which is the last row, contains 2 boxes, how many rows are there? Well, that's what the question is asking. If the term number, which is how many, not term number, if the term value, which is how many boxes there are in a row, if the term value of the last row is 2, what is the value of n that would produce that? Because if n is 14, then that means it's the 14th row from the bottom, but since it's the last row, there are 14 rows. All we have to do here is find out what n is using the formula. Help a fellow out here. Was this it? Okay. So this time the number in the row is 2. I don't like that negative 2n. I'm going to shuffle it off to the other side where it punts the other 2 out of the way. So rearranging it gives me 2n equals 22 minus 2. 22 minus 2 is 20, so we get 2n equals 20. Two boxes is the 10th term. And since 2 boxes is the final row, there must be 10 rows. Okay. You have what I believe is about 20 minutes left, between 15 and 20 minutes left. Yeah. to work on these problems. You will certainly get your quizzes back by tomorrow. You have some questions from the textbook that I would like you to do, some questions from the handout. And when you go to the extra problems on the handout, if you haven't looked at them already, on every page at the bottom of that, it will tell you where to find the answers. So it's organized quite well for you. Any additional problems down here are not for homework, they're just practice. Okay, so get to work on that, please, and give me a minute, and then I'll be around to help you out.
So, do we have any more quizzes like tomorrow?
Pardon me?
Do we have a quiz tomorrow?